All right, this is Investigation 11B, Part 2, and I am down at the bottom where it says, one severe weather outbreak occurred from 8 a.m. Eastern Daylight Time, the 25th of April, to 8 a.m. Eastern Daylight Time, the 28th of April, 2011. Several lines of severe thunderstorms during that period crossed the southeast, spawning tornadoes in exceptional numbers. The NOAA estimates that there were 305 tornadoes in that time frame, so just in those 3 days. During this time, there were an estimated 326 fatalities, meaning deaths. 2 communities particularly hard hit from a single tornado in this group were Tuscaloosa and Birmingham, Alabama. The Birmingham National Weather Service damage report of the 4th of May 2011 noted that the tornado, the one that hit Tuscaloosa and Birmingham in April, that tornado produced over 1,000 injuries and at least 65 fatalities. And here's an excerpt from the report. The National Weather Service meteorologists have surveyed the massive damage associated with this long-track violent tornado. This tornado was produced by a supercell thunderstorm that began in Newton County, Mississippi at 2:54 p.m. Central Daylight Time and finally dissipated in Macon County, North Carolina at approximately 10:18 p.m. Central Daylight Time. Now, that's not the tornado itself lasting that long, although it was a very long-track tornado. They're talking about the supercell thunderstorm that spawned that tornado. So that supercell thunderstorm was much more long-lived than a typical thunderstorm. Okay? And it's typically thunderstorms that are called supercells that will spawn tornadoes. Okay? All right, it says, so this supercell existed for about 7 hours and 24 minutes, traveling approximately 380 miles, producing several strong to violent tornadoes along the way. Okay, we're going to switch over to the next page, and you're going to need to be looking at Figure 2, and so I'm going to pull that up, and you're just going to listen and follow along as I go over this. Okay, so this is Figure 2. Figure 2 is a regional map of tornado damage paths across the area of responsibility of the Birmingham National Weather Service Forecast Office, adapted from the National Weather Service Southern Region headquarters as of the 5th of May, blah, blah, blah. Each track is color-coded and annotated according to the highest level of damage observed along the path on the enhanced Fujita scale. So number 3, the Tuscaloosa-Birmingham tornado track is located to the center left of the map area. From the red color coding of the track and the note, which is kind of placed on the Jefferson County label, the greatest damage found along the path rated this tornado as what? An EF 1, 2, 3, 4, or 5, or 0. All right, so the Birmingham-Tuscaloosa track is right here, okay? And the little box that goes with it is right here. It says Birmingham-Tuscaloosa EF4. So it was an EF4 tornado. And if you look down at Table 1, the enhanced Fujita scale for tornadoes is given. And an EF4 means that you had a tornado with 3-second wind gusts of somewhere between 168 and 199 miles an hour. So that's very destructive, which is question number 4. The EF rating indicates that wind speeds in the Tuscaloosa-Birmingham tornado were likely in the range of what? And we just looked. An EF4 is 168 to 199 miles per hour. Okay, so we're going to continue on with the questions about this particular tornado, the Tuscaloosa-Birmingham tornado. So I am on question number... Where am I? I'm on question number 5. Okay, the National Weather Service report gave the tornado start location and time at 33 north and 87.9 west at 4:43 p.m. Central Daylight Time, and the end location and time at 33.6 north, 86.7 west at 6:14 p.m. Central Daylight Time. Comparing these beginning and ending coordinates with the Figure 2 map, with the path on the Figure 2 map, shows that the tornado traveled in what direction? Well, It started over here at 33.0 north and 87.9 west, and it ended here. So that is tracking northeast. So it starts in the southwest and moves to the northeast. So that's a southwest to northeast motion. The tornado was on the ground for a total of how long? Well, if we take 6:14 p.m. and minus 4:43 p.m., give or take a little bit, that's about an hour and a half. Okay. Number 7, from the coordinates in the ground survey, the tornado track covered 80.3 miles. The speed of the tornado over the ground was therefore about what? Well, if it was traveling for about an hour and a half and it covered 80.3 miles, you can take those numbers and figure out how fast it was traveling. So 80.3 miles divided by 1.5 hours is in the 50 to 60 mile per hour range. All right, if we look at the next question, number 8, another aspect of the damage is the total speed of wind against structures. In a rotating column, the wind speed estimated for the EF scale would combine with the forward speed of the traveling column to impact areas with a combined wind speed near what? Okay, so let me explain what they're talking about. First of all, you've got a tornado rotating counterclockwise, okay? So, for instance, if you're talking about a tornado that's centered here, and it's rotating counterclockwise, and it's also, the whole thing is moving this direction, then the parts that are on this side of the tornado are going to get hit harder than sides on this side, because you've got the tornado moving at 50 some odd miles an hour, which is the speed of a car on a highway. That's moving fast. Plus the spinning winds. Okay, so if you're on this side, you're getting the forward speed of the tornado, 50 some odd miles an hour, plus the 100 and however many miles an hour, the 175 or whatever it was, that the tornado is already going. So those things add together. On the opposite side, they're going to work against each other because you're on the opposite side of the tornado, and they're going to subtract. But on one side, they're going to add because of the direction that the tornado is spinning, and on the opposite side, they're going to subtract. So it depends. This is part of the reason why you can see such differences in damage with the same tornado in the same spot, because, are you on the unlucky side where you're getting slammed with both the forward speed and the speed of the tornado, or are you on the, I really don't want to call it the lucky side, but on the other side where the damage is not as great because those two work against each other? Okay, so let's go back to 8. If you have a rotating column of a tornado with wind speeds estimated from the EF scale, which is between 168 and 199, so let's just call it a 180 or so, and you've got a forward speed from number 7, we said that the forward speed of the tornado was 50 some odd miles an hour, then you take that 180, that's the spinning winds of the tornado, and add the 50, which is the forward speed of the tornado, and you can get a combined wind speed near 230 miles an hour, and that's going to be very, very destructive. Okay, join me for screencast number 3, and we're going to address the questions that go along with figure 4, and that should hopefully wrap us up.